All right. Good morning, everyone. Assalamu alaikum. I hope you are able to see my screen and hear my voice clearly. Could anyone please confirm?
Yes, Hussein.
Yes, thank you. All right. So let me just start this recording as well. Yeah, it started. Good. Well, thank you for joining the session. I welcome you all to this simulation-led design for next generation UAVs. Yeah, before we start, I would request all of you, please mute your microphones to avoid any kind of background noise. You can actually use our chat box in order to dropping any questions or concerns. My colleagues are actually monitoring it, and we will respond to it while I'm presenting. Any remaining questions will be covered in the Q&A at the end, so we can have a follow-up after the session itself. Yeah, my name is Mohammed Waseem. I work as a senior application engineer at Fluid Codes. I bring in 10 years of simulation experience, particularly dealing with metallic and non-metallic structures. At Fluid Codes, I am responsible to develop simulation workflows and as well as deliver customer trainings across the region. Just a quick intro about Fluid Codes. Fluid Codes has been an Apex channel partner for ANSYS, and we support engineers across different industries with simulation, training, and as well as the technical support. So we are in the business for the past 25 years, and we are based in 5 different locations, and we work with 250 customers with a strong team of 60 plus engineers with deep industry expertise holding masters and as well as the PhD degrees. Fluid Codes and as well as ANSYS team will be there at World Defense Show 2026. Please visit us if you're attending. Our team and as well as ANSYS experts will be there to discuss your applications and help guide you on the right simulation approach. So you have a QR code there, scan in and please request us for a meeting. All right, let's move to the main part. So before we talk about the simulation led UAV design, let's quickly see why simulation matters in UAV development. See, whenever we talk about UAV design, we always come across with challenges. So in UAVs, we have these 4 challenges. One is coming with the structures, aerodynamics, thermal, and as well as the certifications. But when it comes to the structure side, one of the biggest challenge is that we always need to do a kind of a trade-off between the weight and as well as the strength. So as you know, as many UAV structures are actually made up of composites, so composites are going to fail in a peculiar manner, particularly fatigue, buckling, and crash. So if we wait until the physical testing to find these issues, the cost and time for redesign really becomes expensive. So another main challenge with the aerodynamics is the accurately prediction of aerodynamic forces across different flight conditions, such as takeoff, climb, cruise, and maneuvering. So these aerodynamic loads actually affect the structure, and this is why we couple CFD to structures to understand how your structure is behaving for those aerodynamic loads. And here we are going to evaluate aeroelastic effects such as fluttering. In aerodynamics, we also care about high lift devices and as well as the stability. And when it comes to the thermal management, this is also one of the critical challenge because UAVs will consist of motor, avionics, battery, and so on. So these devices actually get heated up, right? So if this heat is not controlled, what happens? You will have a performance degradation. The battery is going to degrade and it will eventually lose its performance. So we will have to make sure that these devices are in a controlled environment for a proper reliability. And when it comes to as well the certification, ANSYS will give you detailed and validated simulation results. And you can use these results as an evidence for the certificate submission process for the regulatory authorities such as Federal Aviations or European standards. And having said this, you have these four challenges. So how are you going to solve them? So the simulation is the right answer for it. But when it comes to structural solutions, one of the key design challenges that we see is about the topology optimization for the lightweight. So as every system within the UAV, such as wings, motors, landing gears, electronic devices, everything has to work in tandem under demanding conditions, right? So on this slide, you see here how different ANSYS tools map directly onto the UAV systems. So for an example, if you look at ANSYS LS Dyna, so it is used for crash, drop, and as well as the bird strike. If you go with ANSYS Mechanical, so you will be performing static, model, buckling, and fatigue simulations. And if you go with ANSYS Additive, you go with lightweight, lattice, and metallic inserts. And landing gear is simulated using ANSYS Motion. Anything with related to durability and fatigue, you will consider using ANSYS Encode. And ANSYS Sherlock is used as a reliability assessment tool. Now, let me just quickly walk through the structural workflow. The very first step is here we define the physical problem. So before defining the physical problem, we ask as an engineer several questions to ourselves, like what are we validating? What kind of load cases we have? What is that it matters? Are we checking strength? Are we checking buckling? Are we checking fatigue? What is that? So once we have decided a problem scenario for us, we define this in terms of physical statement. And next, we need to establish the material properties. So this is especially important for composites. And you might have been facing this issue where composite properties are different because stiffness and failures are directional. And any assumptions here in definition of material properties will give a large amount of misleading margins. So in order to reduce any uncertainty, we actually use ANSYS Granta to select and validate the right material properties. Once we have done that, the next step is to go ahead and build the right finite element model. So when I say about the right finite element model, we will have to use high fidelity solvers such as ANSYS Mechanical. So here we focus on the element idealization, we apply the loads, boundary conditions, and so on. So more importantly, if you're dealing with the UAV as a global system, we will have to check how those interfaces and connections are going to work. So this model should reflect the reality, how the structure is actually subjected to loads. So when you solve this problem, it should represent the real load paths. In the next step, here you are going to solve the problem and interpret the results with proper engineering judgments. For an example, if you would like to check what is the wing tip deflections, or even if you want to screen some kind of local buckling, you can do that. On top of it, you also have a provision to quickly run the failure assessment checks. And based on this, you will be able to identify some critical areas and decide whether or not the local reinforcement is needed. And finally, we go ahead by defining the optimization. So this is the step where we actually move from validation to the improvement. So for an example, if you're working with, let's say, fixed UAV wing, and here in this optimization, you can vary some parameters like skin, spar, web thickness, ply angles, or even you can change the material property. So as a global picture, it will help you to optimize the design for your given requirements. Okay. So here, this approach that you see is most valuable under the mid-development stage, wherein your early design concepts are taken now into detailed component validation in order to reduce prototypes. One of the key pillars in this workflow is about the material selections. Again, with UAV composite structures, we don't always have complete or reliable material property, right? So we use here ANSYS Granta to validate and select the right material property before we perform the FEA and the optimization. Now, let me show you some of the use cases for real UAV programs. Let me switch to a real case where it talks about bird strike on a composite wing. Now, first thing is why this matters to us. So this bird strike is a sudden high velocity impact, and it can decide whether the wing stays safe or fails. So this type of scenario is also tied up with your certification expectations, like authorities like federal aviations, because they want to know the proof if the structure can still handle the impact or remain safe. So since the requirement is clear, now how does ANSYS help us here? So first, what we do is we build the wing properly using ANSYS ACP. We capture the real laminate, all those plies, the thicknesses, the fiber directions, and that's important because actually composites don't fail like metals, right? So once everything is done, we take this model to ANSYS LS Dyna, and here we represent the bird as a soft body projectile. We are not going to model the anatomy of the bird itself,
Okay.
right? So we represent the bird as
كويس.
SPH, which
ما
is
عندي مشكلة.
yeah, we represent the bird as smooth pottle hydrodynamics, which is basically used to simulate the problem involving extreme kind of deformations and fragmentations. So once that is done, what actually we are looking for in the results? So here we check the overall deformations like local crushing or to see if there are any kind of damages, whether the structure keeps integrity after the strike or not. So if in case it does not meet any of the requirements, the consequence is just straightforward. So the design needs to be changed. Like what you do in terms of design changes, you may add sub local reinforcement or just completely change or optimize your composite layup or geometry and then rerun the simulation again. So you have that confidence for this certification requirements. Now, let's move to a very practical use case of drone landing and drop. Now, why do we evaluate this? Because for a UAV or a drone, the most common damage is just not coming from the flight. It can also come from hard handlings, maybe accidental drop. If you don't check this at the early stages, the drone may even look fine, but internally you can get cracks, loosened joints, permanent deformations, and this can have an effect for the next flight, and this becomes a risky. So what do we do here? We actually simulate two scenarios. One is the normal landing, and the other is the extreme drop case. So here the goal is very simple. The goal is to understand what is a load transfer, what is a stress hotspots, and how the composite frame is actually deforming. So as an output, we understand where the frame bends and what is the permanent deformations, how the stresses are propagating, and particularly since we are talking about composites here, we look for progressive damage through the laminate. And the benefit is clear. So once we identify the weak areas, we are going to change our designs and improve the durability. And therefore, we reduce some expensive drop while accelerating the design iterations. Next, we move from impact response to damage growth, that is the crack assessments in metals and as well as delamination in composites. Now, from a certification point of view, this is the heart of damage tolerant design. So the question is not when does it break? The question is if there is a damage or if there is a crack, already exists in the structure, how can the structure will still safely behave and under the expected loads? So how do we ensure this? So in ANSYS, we perform two simulations. One is for metals, another is for composites. When we go with the metals, we start introducing an initial crack. We identify what is the crack, what is the location, what is the size, and then if run a fracture simulation or even a fatigue crack growth setup and apply their cyclic loads and understand how the crack is growing to grow for a given number of load case. And when it comes to the composites, we here check on the delamination. So composites can fail either because of delamination or debonding. So we have all those modeling capabilities inside ANSYS. We model it and then we simulate and understand when the crack is going to grow and how fast the crack is going to grow. So having said that, how does this help us under the damage tolerant design? So the outputs from ANSYS can help you to understand to set some allowable damage limits. Maybe you can also define inspection intervals of like how often you need to check before it becomes critical. Further, you can also add some local reinforcements or even change layups, design, and reduce some stresses. And by performing all these iterations, you actually prove your design to meet damage tolerant expectation with evidence. Now, let's talk about aerodynamics, ANSYS Fluent. On the aerodynamics part, we use CFD in order to evaluate the key flight conditions. And here we predict the resulting aerodynamic forces. So what do we do? First, we focus on reducing CAD to the solution time so we can screen more concepts early and iterate faster. We then apply the right turbulence modeling so you can compute for lift, drag, and flow separation. And if for you acoustic really matters, we can extend this analysis to area acoustic simulations. So in the couple of slides, we have a case we can talk about more. And then we can couple CFD along with structures to check wing flexibility, aeroelastic risks such as flutter. For maneuvers, gusts, and propeller interaction, we run transient simulations in order to capture those peak loads. With this, let's talk about aerodynamics workflow in the next slide. So ANSYS Fluent has a dedicated aero workspace for external aerodynamics. So the idea is simple. It guides you through the full CFD workflow and reduces the amount of manual setup. So what you do, you start by bringing the mesh input, then the workspace automatically sets the geometry references that you need to calculate for the coefficients. And next, you actually define the simulation conditions like Mach number, Reynolds number, altitude, and so on. From there, it actually applies the solver settings by default. It is automated with those robust convergence controls. And once it runs, it automatically creates those post-processing outputs such as reports, tables, plots as per your design points. And finally, you can quickly actually compare and investigate these results using the built-in tools. Having said that, now let's talk about the challenge. In Aero CFD, things take time because the setup changes. Sometimes it's a wind tunnel domain, sometimes it's a free stream domain. And on top of that, we usually run lots of CFD cases, right? So as the first workspace, it automatically recognizes the domain, whether it is far field or wind tunnel. So you can compute all those aerodynamic coefficients correctly. Second, it also supports the parametric conditions so that you define your full case matrix such as Mach number, Reynolds number, altitude, and so on for different flight path validations. So here the idea is you just run one case for all these and just do the parametric study. And finally, you can organize the aircraft geometry into different components, which improves both setup and as well as post processing. So on the previous slide, we saw how the Aero workspace helps us to set up and run the aerodynamic cases efficiently. Now, once these CFD results are available, the next question is how do we use them on the structural side? Because we also need to check the structural integrity, right? And this is where the concept of fluid structure interaction comes into picture. See, the first benefit is easy parameter transfer. We can directly use CFD results like the pressure distribution, just drag and drop onto the mechanical, and you will see the imported pressure of the CFD. So once you are in the mechanical, you can just use inertia relief option to solve the UAV under real flight conditions. Okay, so far we actually covered the workflow. That is, we do the aerodynamics in Fluent and then we transfer the loads for FSI, right? So now let's make something real with a quick case study from Dronamics. So they have used ANSYS to optimize a cargo UAV. I like this case study specifically because it matches exactly what we have talking been so far. That is using simulation to improve UAV design and performance. On the left, you can see their goals. They wanted to optimize fuel efficient cargo aircraft that will reduce some cost by 50%. And they wanted to shorten design iteration cycles and so on. So on the solution side, it's only main three things. One is connect CFD to handle complex turbulence, perform FEA, and manage composites with the pre-processing ACP. So the idea is simple. You start with a high fidelity aerodynamics simulation, which is ANSYS Fluent. Then you define composite layup for the UAV structure. And then you also include those 3D engine brackets, components, or any kind of metallic inserts that you have in the UAV. And then finally, use the pressure distribution to run wing simulation inside static structure under the aerodynamic loads. Up to now, we actually talked about how aerodynamics and FSI comes into role. The next big topic here is about UAV or drone noise. So this noise has to be mitigated because it will affect the regulatory compliance, community acceptance, operational safety, and mission effectiveness. So the main challenge here is to predict the noise coming from propellers and as well as the rotors. So how ANSYS solves the problem? So it's simple. Let me just break down. First, you will have to use ANSYS Fluent, ANSYS Fluent to capture the turbulence models like URANS and SRS. So they are going to evaluate the highly aerodynamic interactions that generate the noise. And then Fluent gives us an option for aeroacoustic problems like broadband noise methods in order to predict the noise in detail. So the step 3 is to evaluate the psychoacoustic analysis. So ANSYS Sound is integrated with ANSYS Fluent. So we can generate those sound files and even listen to them. The image that you see here is a pressure field around the routers, and this is the CFD output coming from ANSYS Fluent. So the velocity counter near the rotor, here, this is where the noise sources are coming from. Hence, we use URANs and SRS to capture complex time-dependent aerodynamic interactions. And bottom plot, you see here, this is with noise versus frequency. So the peaks that you see uh, highlight the main rotor tone, and it repeats at higher frequency. And as you can see, as the frequency increases, so those tones typically reduce and fade out. Again, how do we do this? So we use ANSYS sound to generate sound files and evaluate how the noise will be perceived. Now let's listen the simulated sound. Yeah. So this sound is simulated, and you can use ANSYS Fluent along with ANSYS Sound to generate these sound files and evaluate how the noise will be perceived. All right. So moving on, besides performance, another thing that decides UAV reliability is about the temperature control. So in a UAV, heat builds up in compact areas like motor, battery pack, electronics, and the data links. So if we do not manage it, we can get some performance drop, reduce battery life, sensors, or even some computer errors. So now the key point is thermal reliability is not only one tool, it's the whole workflow. So we combine right ANSYS products depending upon the requirement. So for an example, you have ANSYS motor and propulsion as a physics. So you're going to use MotorCAD plus mechanical and fluent to understand those losses and to see how the heat is actually removed. For battery packs, we actually going to use ANSYS Fluent, and if needed, we also connect that with the mechanical to perform a multi-physics simulations. For the data links and as well as the electronics, we use ice packs to predict the board level and enclosure level temperatures and as well as the hotspots. So this just gives you a flavor of how temperature looks like. On that scenario, this is the summary of what we have covered today. One is the performance, reliability, and coupled field uh, multi-physics challenges. If you would like to have a deeper discussion or let's say a tele demo, please feel free to reach out to us at sales@fluidcodes.com, and we will be happy to help you. And that's all from my side. I think it's a quick session. If you have any questions, please type in the chat or unmute and go ahead. Okay. Well, there is one question. Can we use ANSYS explicit for drone drop instead of ANSYS LS Dyna? Yeah, it's a very good question. Now, just to have a kind of a clarity, ANSYS Explicit Dynamics is coming along with ANSYS Mechanical Enterprise License. So with Explicit Dynamics, you will be able to perform drop test scenarios, impact and detonation kind of challenges. So ANSYS Explicit Dynamics uses Autoden solver in the background, But whereas on the other hand, LS-DYNA, which is an industrial leading finite element tool, can also be used to simulate highly nonlinear transient problems, such as impact, blast, ballistic kind of scenarios. So in a given scenario, let's say you are trying to simulate the drop test of a drone itself. So wherein your interest is just to understand how the deformation is looking like. On that scenario, you can just go ahead with ANSYS explicit dynamics. But if your interest is to understand how the failure is going to propagate through the thickness of the composite laminate, then you will have to use ANSYS LS Dyna for it, because ANSYS LS Dyna is offering you a broader physics. It has a lot of advanced contact and material failure modeling options. So, on that scenario, you will have to use ANSYS LS Dyna. I hope this clarified your concern. Also, there is a next question on, you mentioned about ANSYS certification for drone and UAVs. Could you explain how this can be leveraged? All right. Yeah. So as I mentioned in the first slide, ANSYS simulations will provide you detailed and validated results. And these results, you can use it for the certification process. Okay. So for an example, here in Saudi Arabia, it is GACA, General Authority for Civil Aviations, right? So those are the ones, or the regulatory national standards. So they are going to interpret the results of simulation results based on their test standards and internal protocols. And based on that, they will give you the approvals for the UAV or the drone. So ANSYS, this is how ANSYS is actually helping you, to reach to the application of the certification through our simulation results. I hope this is answered. So how does team to team workspace sharing work? So Khalifa, can you be clear if your concern is about the CFD workspace here? Please feel free to unmute.
Hello, yeah. My concern is because we have aerodynamics teams and basically mechanical or structural engineers, and both have their own expertise in their field. So if we have a workflow for aerodynamics, and aerodynamics will update and upgrade their simulation and produce new results, for example, how does this transition to other teams? And is there a way, for example, for both teams to work on the same workspace, or does each team will produce their own and then send the data for the other team, and this need to be updated regularly?
Yeah, true, true. So it's a nice question. Let me answer this one. See, if you want to perform a CFD simulation, particularly on the FSI, let's say, you can couple the CFD results directly to the structural part using this coupling, which is a very straightforward. So normally, if you want to work as a different team, let's say CFD files are normally huge, and you cannot pass the CFD files every time to the structural team. So maybe CFD team can just share those aerodynamic forces as a pressure input in the form of a text file, and then use ANSYS Mechanical as an external data to input those pressure files. So that's one way. The other way is, if both of you, CFD and the structural team, wants to work together, so there is something called a system coupling inside Mechanical Workbench. So you can couple your CFD results to the mechanical one, and mechanical one to the CFD. So this way you can have two-way kind of interactions. So in both scenarios, it is possible. I hope this answered your question, Khalifa. Okay, perfect. So there is a next question. I saw you mentioned about inertia relief. How does it work similar to other commercial CAE tools. Yeah. So yeah, inertia relief is an option which is there in ANSYS Mechanical in order to simulate the bodies which are flying, because you cannot fix a body which is flying in the air. For an example, UAV, or let it be a ship sailing in the sea. You cannot fix it, right? So inertia relief is an option wherein you check the ANSYS solver is going to apply some, uh, calculated acceleration loads, and this will balance using this particular option. So that's a possibility. Here you are not going to apply any fixed supports, but rather you are going to apply some artificial accelerations in order to simulate it. So it's a very good feature, and it is available for both linear and as well as non-linear analysis. You just need to turn this on. Okay. When performing aeroelastic analysis such as flutter or gust for UAVs and external stores, which ANSYS solvers are typically used for ground vibration testing, correlation, and how reliable is the coupling between structural dynamics and aerodynamic models within the ecosystem? Yes, this is a very good question, and I will actually let this to be handled by our subject matter expert. Hari, if you're there, maybe you can guide this.
Yeah, hi Wasim. Thanks for the question, Ms. Aisha. So this we can combine again like an FSI analysis only. There are two options, what we call it as intrinsic FSI in Fluent, where you can able to simulate the Flutter kind of responsibility, and the Fluent have certain capability to do the FEA analysis or structure analysis part also, but it is very limited, intrinsic in level. So that will be the first cut solution that we can proceed for the flutter or gust responses for the UAV in terms of aeroelasticity. Uh, the second part of the question I saw, like there was a question with respect to ground vibration testing correlation and the reliability between structural dynamics and aerodynamics model within an ANSYS ecosystem. So that comes up with a lot of testing and validation. Straight away, if you're going to run something and expect a validation with the ground vibration testing, it will not be happening. Definitely, there will be tuning and modeling approach has to be tuned to get most reliable one, and it varies from case to case basis. And each and every individual OEMs have their own way of evolving the methodology for that. So that itself is a separate project that the companies use to work here. So again, on the coupling side, whatever we have seen from the Wasim is going to be the same approach we have to do for the aeroelastic analysis. But on the validation side, it will have back and forth of calculations and methodology evaluation has to be done.
Perfect. Thank you, Hari. So we have a question from Sultan. So do you have coming session on coupling simulation between CFD and structures? Inshallah, Sultan, we will be having it. So this is the idea of organizing the webinars. So if you are passing by on the defense show, let's meet together and decide upon what kind of topics you are interested, and maybe we can have a separate discussion on this, or even post it a webinar similar to this. Thank you. Okay, there is a question again. I missed your part on thermal cooling. Can you please mention which tool is that? Yeah. So for the thermal cooling, we are going to use ANSYS Ice Pack, which is a CFD solver useful for PCB enclosures in order to check how reliable cooling is. So that's ANSYS Ice Pack, this part. All right. All right. So if there are no more questions, I would like to thank everyone for those great questions and the discussion. Before we close this, just a final reminder. If you're visiting the World Defense Show, please come and meet us at booth E24 Hall 1. Fluid codes and ANSYS experts will be there to discuss your programs and recommend the right simulation approach. Please scan this QR in order to request for the meeting. And personally, I will also be there, especially to support on structural and composite topics. So please feel free to drop to say hi. So thank you again for your time and have a great day.
Thank you, Waseem.